All right, so there's different types of problems we can ask with these unit cells beyond just kind of knowing the basic facts about them. Check out your book for more examples, and of course the work along. These can be quite tricky, so definitely do a couple of them. Some things that you need to know. You need to know the relationship between the radius and the edge length, and that depends on which type of packing that you've seen, right? So we've talked about that. You need to know other facts about, how many atoms there are per unit cell, that kind of thing. You need to know what the volume of a cube is. And the volume of a cube is the length cubed, right? Where L is our edge length here. We need to know that density is equal to mass over volume. And of course, we also need to know that there's 10 to the 12 picometers in 1 meter, right? So these things are usually measured, like edge length and stuff are usually measured in picometers, or even atomic radius in picometers, that kind of thing. You can solve these problems in a bunch of different ways. So the way I do in this video might not be the way that works for you. You should really do a couple practice problems and see, how well you do in it and that kind of stuff. So our first practice problem says that calcium crystallizes in a face-centered cubic with an edge length equaling 558.8 picometers. Find the radius and density in grams per centimeter cubed of calcium. So in terms of the radius, right, that one's probably pretty simple. We know it's a face-centered cubic structure, and so we know the edge length is equal to r times the square root of 8. Since we want to solve for r, we can reorganize the equation by dividing both sides by the square root of 8. And then we simply take this 558 value, plug it in there, divide by the square root of 8, and we get a radius of 197.6 picometers. So pretty cool with X-ray crystallography. You can find the atomic radius of certain compounds. The next thing that we want to know is the density of the compound. So we know that density is equal to mass over volume. And so we can solve for each of these independently or all at the same time. It depends, there's different ways to do it. Feel free to do it whichever way makes you get the answer correct. So in terms of mass, we want to think about how many atoms we have in that cell and then how much that weighs. So we know that we're a face-centered cubic. We know that face-centered cubic have 4 atoms per cell. And so we can think about it as 4 atoms. Well, how much do 4 atoms weigh? Well, if we're talking about the mass of a compound, we know it's molar mass, which is grams per mole. And then, of course, we can relate moles to the number of atoms using Avogadro's numbers. So we can use 4 atoms divided by 6.022 times 10 to the 23 atoms in 1 mole. Our atoms and our atoms cancel out. And then we can use the molar mass of calcium, which is 40.078 grams per mole. And now we can see the mass of our 4 atoms, and that'll cover the mass part of density. So you get 2.66 times 10 to the negative 22 grams, which is a very small number, but it makes sense that it's a small number. It's just the mass of 4 atoms, which is, absolutely tiny. Then the other component that we want to know is volume, right? That's the other part of density. We know that our volume of our cube is equal to the length cubed. And so we also know that 10 to the 12 picometers is equal to 1 meter. And so we can take our edge length and convert it from picometers into centimeters, because we eventually want centimeters cubed to get in our volume. So we have 558 picometers. we can say that there's 10 to the 12 picometers in 1 meter. And then every 1 meter has 100 centimeters. And then you get 558.8 times 10 to the negative 10 centimeters. We, of course, know that volume is length cubed, so we can take this length here and cube it. And then it'll become centimeters cubed. And I got 1.74 times 10 to the negative 22. Note, be careful with the operations and the order in which you do these things. If you, for example, cubed it first, you would have 1 picometer cubed. And if you wanted to convert that into meters, you have to do 10 to the 12th cubed as well. So it's actually divided by 10 to the 36 to go from 1 picometer cubed to 1 meter cubed. So just be careful of that conversion. Or you can convert it to centimeters first, and then you don't have to worry about it. And then finally, right, we know density is mass over volume. We've solved for the mass and the volume independently, and so we can just plug them in. And you get 1.53 grams per centimeter cubed. Again, these problems are tricky. The only way around them is to do some practice.